artificial intelligence is no longer just a futuristic concept. It has become a part of our everyday lives, powering chatbots, recommendation systems, voice assistants, self-driving cars, fraud detection, and much more. But here's something that often goes unnoticed. AI cannot exist in isolation. It cannot make decisions, learn, or generate insights without data. And ensuring that this data is reliable, high quality, and available at scale is exactly the role of data engineering. In fact, if AI is the brain of the future, then data engineering is its backbone. Right now, data engineers are responsible for building the pipelines that collect, clean, and move vast amounts of data from different sources into systems where AI can use it. Imagine all the raw data being generated every second from smartphones, IoT devices, sensors, and applications. This raw information is messy, incomplete, and often unstructured. Without data engineers, this information would remain useless. They transform it into structured, consistent, and meaningful datasets that AI models can actually train on. In simple terms, data engineers make sure that AI has the fuel it needs to function. But as AI continues to advance, the demands placed on data engineering are also changing. Traditional pipelines that process data in daily or weekly batches are no longer enough. AI models, especially those used in critical applications like fraud detection or autonomous vehicles, require real-time access to data. This shift means that data engineers are moving towards systems that can handle streaming data, capturing events as they happen and feeding them into AI systems instantly. The complexity of AI models also means that the scale of data is growing at an exponential rate. To handle this, data engineers are embracing new architectures like the data lakehouse, which combines the flexibility of a data lake with the reliability and performance of a warehouse. We are also seeing a rise in tools that bring automation into data engineering. Data quality monitoring systems are now able to automatically detect errors or inconsistencies and fix them before they ever reach an AI model. This is crucial, because bad data doesn't just lower the accuracy of AI. It can lead to biased or even harmful outcomes. At the same time, practices like MLOps and DataOps are becoming more popular, helping organizations manage the entire AI lifecycle with the same discipline and reliability that software engineering teams apply to applications. These approaches allow data engineers to collaborate more closely with data scientists and machine learning engineers, ensuring that data pipelines are seamlessly connected to model training and deployment. This brings us to the skills that will define the future of data engineering. It will no longer be enough for data engineers to simply move data from one system to another. They will need deep expertise in distributed systems, cloud-native technologies, and real-time processing frameworks. Knowledge of automation, orchestration, and large-scale storage solutions will be essential. But perhaps the most important skill of all will be an understanding of how their work directly affects AI outcomes. Data engineers of the future will need to think not just about efficiency and scalability, but also about fairness, transparency, and ethics in the way data is collected, processed, and delivered. After all, AI systems are only as ethical as the data they are trained on, and data engineers will play a vital role in maintaining that integrity. In conclusion, while AI may capture most of the attention as the technology of the future, it is data engineering that quietly ensures AI can thrive. Without strong pipelines, without accurate and timely data, even the most advanced AI would fail. As artificial intelligence continues to grow more sophisticated, data engineering will not only remain relevant, but will become more important than ever before. The future of data engineering is about scale, speed, and automation, but it is also about responsibility and impact. In the age of AI, data engineers will not just be building pipelines, they will be shaping the foundation of intelligent systems that have the power to transform industries and societies.